Hi and welcome to the continuation of the LAS instructions that I'm giving to you at Anasov, Gates, Hollerith, Hopper, Iverson, and Neumann. Welcome to quarter 4, week 6. The topic for this week is about heat, work, heat transfer, and heat engines. Okay, so basically it starts with the following questions. The writers would like you to ponder on the following questions. So first is, why do objects get hotter or colder? Bakit daw umiinit at bakit din lumalamig yung mga bagay-bagay? The temperature is a measure of how hot an object is. Alam natin yan. When we talk about temperature, it refers to yung mismong lamig or init ng isang bagay. Ang heat transfer naman as a term only takes place kapag merong temperature difference. The heat energy flows or thermal energy flows from a warmer area to a cooler area. What it wants you to ponder on is something you already know eh. Alam mo na to, 'di ba? That heat transfer can only happen or thermal energy can only transfer from a body of higher thermal energy to a body of lower thermal energy. Yung init, natatransfer lang siya mula dun sa mainit na bagay papunta dun sa mas malamig na bagay. Well, hindi naman siya literal na malamig, pero it may be having a lower temperature than the other object that is hotter. Okay, so the next question naman is asking you to ponder on something that commonly takes place in nature. Why does an ice lollipop melt on a warm tongue? Ice lollipop, I think we're referring to a popsicle. Popsicle. So there is a temperature difference between the tongue and the lollipop. So heat energy flows from the warm tongue into the cold lollipop. Yung kapag kumakain ka ng popsicle, yung init ng dila mo, natatransfer yun dun sa mismong popsicle. Kaya ang nangyayari is yung popsicle, it melts. This heat transfer means the ice lollipop melts as it gets warmer and the warm part of the tongue touching it gets colder. Kumbaga parang yung difference nila in terms of temperature upon contact, parang mai-equalize yun. So yung mas mainit, maglo-lose siya ng init. And then yung namang mas malamig, mag-gain siya ng init. Yan. Heat naman is, as a term, is simply the transfer of energy from a hot object to a colder object. So yung the coffee and the mug are transferring heat to the surroundings as well as the lollipop or popsicle to the tongue. The heat transfer occurs from the hot area or object to the cooler object. So it's just basically reiterating everything that we already talked about. Okay. The next topic being discussed by your LAS are the three methods. I think they're supposed to be three. Yeah. The three methods of heat transfer. The first one is through conduction. Conduction is a manner of heat transfer that is done through physical contact, so solid to solid. The matter is stationary. Ito siya. So, let me just highlight it. The matter is stationary on a macroscopic scale. Tapos, we know that there's thermal motion of the atoms and molecules at any temperature above absolute zero. So, heat transferred between the electric burner of a stove and the bottom of the pan is transferred by conduction. So, kapag halimbawa, yung burner, mainit siya, tapos na-touch niya yung bottom ng burner, iinit yung bottom ng pan, iinit yung pan. Okay, so halimbawa din is, mainit yung mug, tapos hinawakan mo siya, so your hand is more or less solid, tapos the mug is also solid. Yung heat na transfer sa kamay mo through conduction. Convection is the heat transfer by the macroscopic movement of a fluid. So this type of transfer takes place in a forced air furnace, and in weather systems, for example. Convection involves fluids. And in physics, pag sinabi nating fluids, it means liquids and gases. Yung mga may kakayahang mag-flow. Okay, so in this example, kahit na air ang pinag-usapan dito, that is convection. Okay, tapos kapag halimbawa naman, yung tubig is mainit, tapos nilagyan siya ng, sabihin natin na, halimbawa, kumukulo yung tubig, tapos nilagyan siya ng itlog, tapos yung itlog is just floating. So, uminit yung itlog, and the contact was through water. So, we can also say that is that is heat transfer done through convection. The last one naman is called radiation. Ang radiation, it happens naman kapag involved na yung mga waves. Okay, so halimbawa, microwave, infrared radiation, visible light, or any other form of electromagnetic radiation that is emitted or absorbed. Ang obvious example dito is yung pagta-transfer ng thermal energy ng sun papunta ng earth. Hindi tina-transfer ng sun yung thermal energy sa pamamagitan ng conduction. Like, hindi naman siya physical na nakatouch sa earth, di ba? Hindi rin siya nagta-transfer through convection. Like, wala namang hangin between, there's no air. There are parts of the solar system between the sun and the earth that don't really have air. It doesn't really have air between that. So, we can't also say it's through convection. So, but we're sure that it was transferred because of the movement of the electromagnetic waves, and that is done through radiation. So remember the three. Heat is simply transfer of energy. It's again redefining. I don't know why the writers keep on saying this, pero maybe their point is that you have to remember. Okay, don't forget what the meaning of heat is. A transfer of energy to or from a system by any means other than heat is called work. You're familiar with this. Work in physics is the measure of energy transfer that occurs when an object is moved over a distance by an external force. Remember, the two terms here are distance by an external force. Remember that work is equal to force multiplied by distance. Okay, so the next part of this LAS is discussing heat engines. Why is that so? Because it is where mechanical work is produced by heat. Okay, so ang init, ang thermal energy, it has the ability to create work. Okay, it has the ability to do work. In the same way as other energies, forms of energy can also do that. Okay, so a heat engine in this discussion is a device used to extract heat from a source and then convert it into mechanical work that is used for all sorts of applications. Halimbawa, a steam engine in an old-style train can produce work. Ito, example dito. Just focus here, maybe. Ito. Could produce work needed for driving the train. Several questions emerge from the construction and application of heat engines. Okay, so this is figure 1 right here. This is an internal combustion engine burning coal, and then there is this water tank. Tapos yung water tank, since it's directly connected to the coal burner, it produces steam, and the steam has the ability to push the piston. Okay, and then the piston now is what is going to turn these crankshafts para mag-move yung train. Okay, again, I don't think I have to tell you this in details. Let me just remind you that when we were making the discussions regarding thermal energy, steam, ayan, yung steam mismo, okay, this has the ability to make things move. In this case, it's the piston. Okay, so I think this is supposed to be figure number 2. Okay, so for figure number 2, It shows how heat can do work in a heat engine. So whenever we consider heat engines and associated devices such as refrigerators and heat pumps, we do not use the normal sign convention for heat and work. The input here is right, ito, nandito siya banda. And then, the output is right here. And as you can see, not all of the energy is, not all of the thermal energy is used up to do work. Okay, just a part of it was used to do work. The others are just put in some sort of a reservoir. For convenience, we assume that the symbols QH and then QC and W represent the amounts of heat transferred. So, the heat transferred and work delivered. So, these are heat Q, tapos work naman is work done, W. Okay, regardless of what the givers or receivers are, whether heat is entering or leaving the system and work is done. So, yun siya. The engine is right here, dito siya banda. The engine has the ability to process input heat and then put it in a reservoir and then produce work. Assume that the heat engine is constructed between a heat source, high temperature reservoir or hot reservoir, and then a heat sink or a cold reservoir. So represented schematically on in here, dito sa taas. The engine absorbs heat from a heat source of Kelvin temperature, uses some of that energy to produce useful work, and then discards the remaining energy as heat into a heat sink or a cold reservoir. Again, it receives the thermal energy from a hotter source, okay, heat source from a cold hot reservoir, and it's gonna use that thermal energy to do work. But not all of that thermal energy that was coming from the input is going to be used for work. Some of it is going to be discarded into the cold reservoir or the heat sink. Okay, now suppose that the engine the above one, okay, goes through one complete cycle, and that QH and QC and W represents the heats exchanged and the work done for that cycle. Therefore, work is going to be equal or must be equal to the difference between the heat from the hot reservoir and the heat from the cold reservoir. Kapag pinag-minus mo daw yung thermal energy na nandoon sa hot reservoir, okay, and yung thermal energy na nandoon sa cold reservoir, kailangan yung makukuha mo is yung work na nagawa nung system. The most important measure of a heat engine is its efficiency. So, letter E. Nandito na tayo niyan sa part na to. Yes, it's a new topic. Alam mo na kung anong heat engine, okay? A heat engine has the ability to use thermal energy from a hot reservoir to do work, and then the excess or the other thermal energy that was taken in was going to be discarded, as in tatapon na siya into the heat sink. Tapos, in-explain ko na rin dito that para malaman kung gaano ba karaming work yung nagawa ng mismong heat engine, kailangan mo lang i-minus yung amount ng heat na natira para sa cold reservoir mula dun sa amount ng heat na pumasok dun sa heat engine. Okay? Now, in physics, in these kinds of topics regarding heat engine, importante ang konsepto ng efficiency. Gaano ba kagaling yung heat engine? Gaano ba siya ka-efficient mag-convert ng thermal energy from the input to work? Okay? May mga heat engine kasi na since bago pa sila, kayang-kaya nila na masulit yung input na thermal energy. Pero may mga heat engine din na dahil na rin sa kalumaan nila, masyado nang marami yung natatapon na thermal energy. Now, how do we measure that? Okay, so it's by dividing the amount of thermal energy that was, the amount of work that was created, work output, divide that by the amount of heat that was taken in by the heat engine. With the heat engine working between two reservoirs, we get out work and put in, we get out, or we are going to have or to produce work. And then to do that, we have to put in some thermal energy. So the efficiency of the engine is going to be QH. So that's QH minus 1 minus QC over QE. Okay. I know that is quite a different kind of formula, pero I think it's better if we see it in a sample problem. In this sample problem, an engine absorbs 4,500 joules of heat energy or thermal energy from a hot reservoir. So yung input niya is 45 joules. Okay? Tapos yung nailagay, yung natapon dun sa mismong cold reservoir is 2,500 joules. So given yung QH at saka QC. Yan sila. So yung first question niya is how much work daw is performed by the heat engine. Tapos yung pangalawa naman is pinapacalculate yung thermal efficiency ng engine. Okay, so the missing factors are work done and then efficiency. So mali lang yung pagkakalagay nila dyan. Na masyado siyang napunta sa right. For the solution, part 1, simple, just kunin lang natin yung difference nila. So 45 minus 25 is going to be 2,000 joules. Okay, and this gives us the value for efficiency. So yung work output is 2,000 and yung work input naman, yung nandun sa hot reservoir is 4,500. Therefore, the efficiency is 0.44 or 44%. So, ibig sabihin yan, ganyan siya ka-efficient. Hindi siya gaano efficient. Kasi, kailangan kasing dami, okay, nung input yung output. Dito, yung input mo is 4,500. Tapos, ang nagawa lang niyang work is 2,000. Hindi man siya nangalahatin. So, ibig sabihin, hindi siya ganun ka-efficient. Kaya, 44% lang yung nakuha natin. Kapag halimbawa, meron ng heat engine na nakagawa ng 4,500 yung input, tapos 4,500 din yung naging output, well, that's gonna result to 100% efficiency. And so far, wala pang ganong klaseng engine na nag-exist sa paligid natin. Okay, yun na ma-maximize talaga yung energy input. Okay? Okay. So, the learning competencies that you're supposed to master are the following. You have to be able to construct a model to demonstrate that heat can do work. And then you also have to explain how heat transfer and energy transformation make heat engines work. Okay. Now, please listen to the activities that you are supposed to do. Activity 1, heat list. I am not going to ask you to do this activity. Maybe you want to do this if your hobby is through crosswords, pero we're not really going to achieve our objectives, our learning competencies if you spend time doing this. It's fun, but it's not really going to let us achieve our competencies. Okay. Next one is hit all you can, part A. You have to do this. Okay, you just have to fill in those blanks with the missing term or terms. Make sure that you check your own work and make sure as well that you indicate your score. Okay? A photo or screenshot of your answers must be posted in your portfolio. Okay, so part B naman is you have to solve for the following problems. You have here 3 problems, and what you need to do is just to solve them. Make sure that you check your own work. Okay, the answers key for both of these activities, for both of these letters for activity number 2 are found at the end of your copies of the LAS for quarter 4. So make sure that you show the complete solution, indicate the givens, write your full solution, box your final answers. Tapos please check your work, especially, sige, you can focus on the final answer lang, the boxed one. Pero I will be looking for your for your solution so that I can see as well your process. Okay, a photo or a screenshot of those. Again, the givens, the procedure or the solution, and then the complete answers must be posted in your portfolio. That's it. You notice that we are about to end this series of last instructions because week 7, the last week for for science is approaching. For the meantime, what I would like you to be reminded of is make sure that you have completed all of your portfolio entries by now. Okay? Make sure that you also have taken the quizzes so that wala na tayong aberya by the end of this quarter. Okay, so that's it. I'll see you in the last instructions for ano na yun, for week 7.